If y is equal to 2x minus 8, what is the minimum value of the product x times y? This is a classic example of an optimization problem. In optimization, we are asked to maximize or minimize the value of some function. Here, our function is the product x times y. So we can write P for product is equal to x times y. The first step of optimization is to figure out what exactly you are optimizing. Well, here we are optimizing P, the product. We want to find the minimum value of that product. Well, let's go back to our first derivative analyses. If P has a max, that means that P prime changes from positive, because P prime is the slope of P. P prime changes from positive to negative. Likewise, if P has a min, that means that P prime changes from negative to positive. Furthermore, the max or min occurs where the derivative is either equal to 0 or where the derivative is undefined, like a cusp or a corner. So, we have a couple things to think about here. Number one, we're going to have to do a first derivative analysis on our function that we are optimizing, P. But more than that, in order to do our first derivative analysis, we have to turn P into a function of only one variable. Here, P is in terms of two variables. How can we get P in terms of only one variable? And that's the other part of optimization. You are usually going to be given a secondary piece of information that will help you solve for only one variable. Here they told us that y is equal to 2x minus 8. That's huge, because we can substitute in 2x minus 8 for y, in which case we only have one variable now. So in optimization, you always want to get your function that you're optimizing in terms of only one variable. So, here we have P is equal to x times y, which is 2x minus 8. And finally, P is equal to 2x squared minus 8x. Of course, we can now find dp dx, the derivative of P with respect to x, to perform our first derivative analysis. So, dp dx is equal to 4x minus 8. And to find the critical points, we can either set this equal to 0 or see where it is undefined. Well, this is defined everywhere, so we'll just set it equal to 0. This means that x is equal to 8 over 4, which is 2. And it's at this point that we can perform our first derivative analysis. So here's the graph of P prime, and here's x equals 2. Let's plug a number to the left of 2 into P prime to determine whether P prime is positive or negative to the left of 2. How about 0? If you plug 0 into dp dx, you get negative 8. That's negative. Let's look to the right of 2. How about 4? If you plug 4 in, you get 8. That's positive. So P prime at x equals 2 is changing from negative to positive. That means that we have a relative min at x equals 2. And what that means is that P prime is going from negative to positive, and so P has a minimum at x equals 2. The question though was, what is the minimum value of the product x times y? Well, the product can be rewritten as 2x squared minus 8x. If you plug 2 into here, 2 times 2 squared, well 2 squared is 4, times 2 is 8. So this is 8 minus 8 times 2 is 16. And so the minimum product is negative 8. Let's go through this one more time. We first found a model for the variable in which we are optimizing. That was our product. It's x times y. We then realize that we have to get this model in terms of only one variable. Luckily, they're going to give you information to be able to find that one variable. Here they told us that y is 2x minus 8. So p is equal to 2x squared minus 8x. The next step is to do our first derivative analysis in order to determine where there is a relative min. Well, we located a relative min at x equals 2, and we verified it using our first derivative analysis. Because p prime is changing from negative to positive, there is a relative min at x equals 2. When you plug that back into your product, that should give you your minimum product. And of course, the minimum product is negative 8.